Good morning. On the last period we have seen working of transistor, types of transistor, working of transistor. Now today we have to see transistor characteristics. Transistor characteristics. Today we have to see transistor characteristics. Circuit diagram. Consider common emitter configuration. To study the transistor characteristics, we have to use common emitter configuration. To study transistor characteristics, we have to use common emitter configuration. Consider common emitter configuration like this. Consider common emitter configuration. Consider common emitter configuration. Consider common emitter configuration like this. Here we consider NPN type transistor. NPN type transistor like this. Hit the base. Emitter, base, collector. Emitter, base, collector. Now see. Emitter, base, collector. For normal operation of transistor, emitter base junction is forward bias. Emitter base junction is always forward bias. Hit the base current. Here base current, that is IB. Base current IB. For normal operation, emitter base junction is forward bias, means positive, negative like this. Positive, negative, this is potential between emitter and base. Potential between emitter and base. Base collector junction is reverse bias. Base collector junction is reverse bias like this. Base collector junction is reverse bias with potential. Reverse biasing. Reverse biasing means reverse bias, that is negative, positive like this. Positive, negative, potential between emitter and collector. Hit the collector current, that is IC. Collector current, that is IC. Collector current IC. Okay. Now see. Here the potential between emitter and base, potential between base emitter and collector. This terminal is grounded. Simple circuit connection. Now see, transistor characteristics. To study characteristics of transistor, consider common emitter configuration of NPN type transistor. To study the characteristics of transistor, consider common emitter configuration of NPN type transistor. Emitter base junction is forward bias, while base collector junction is reverse bias. Now, first input characteristics. Input characteristics. Input characteristics. The variation of base current IB. Variation of base current IB with potential between emitter and base. म्हणजेच इनपुट पोटेन्शियल आणि बेस करंट, व्हेरिएशन ऑफ बेस करंट IB with potential between emitter and base, म्हणजेच या दोघांमध्ये व्हेरिएशन at constant potential between emitter and collector. At constant potential between emitter and collector is called input characteristics of transistor. The variation between base current IB with potential between emitter and base at constant potential between emitter and collector is called input characteristics. If the graph of base current with potential between emitter and collector is plotted, then nature of graph is like this. Base current IB, potential between emitter and base at constant potential between emitter and collector. Suppose this one as barrier potential. VB. Suppose this one as barrier potential between emitter and base. If potential between emitter and base is less than barrier potential, if potential between emitter and base is less than barrier potential, then very small or nearly equal to zero current flows through base. Means IB is very, very small and nearly equal to zero, like this. If potential between emitter and base is less than barrier potential, then current IB is nearly equal to zero, and therefore graph is like this. Second, if potential between emitter and base is greater than Vb, or potential between emitter and base is greater than barrier potential, then this junction acts as forward biased PN junction. Forward biased PN junction, and therefore base current increases like this. If potential between emitter and base is greater than barrier potential, then junction between emitter and base acts as forward bias and current increases. Now, input dynamic resistance. Input dynamic resistance. The ratio of potential between emitter and base to the base current IB at constant potential between emitter and collector. This ratio is called as input dynamic resistance, that is RI. What is input dynamic resistance? The ratio of change in potential between emitter and base to the change in base current at constant base collector potential is called as input dynamic resistance. Okay. Now, output characteristics. Second one, that is output characteristics. Output characteristics. Output characteristics. The variation of collector current IC, the variation of collector current IC here, collector current IC with variation of emitter collector voltage at constant base current, variation of collector current IC with potential between emitter and collector at constant base current IB is called as output characteristics of transistor. Input characteristics, variation of base current with potential between emitter and base at constant potential between emitter and collector. And output characteristics, variation of collector current with potential between emitter and collector at constant potential between at constant base current is called as output characteristics. If the graph of collector current with potential between emitter and collector is plotted, then nature of graph is like this. Collector current IC with potential between emitter and collector. The nature of graph is like this. The variation between collector current IC with potential between emitter and collector at constant base current is called output characteristics. From this graph, collector current IC is independent of, initially collector current increases but then remains constant, means collector current IC is independent of potential between emitter and collector as long as collector emitter junction is reverse bias. Also collector current IC is large for large value of base current. Base current IB1, suppose IB2, IB3, means as base current increases, collector current also increases. From this graph, initially as emitter collector potential increases, current increases, collector current increases but remains constant, means collector current is independent of potential between emitter and collector, but this collector current increases with increasing base current. Okay. Now output dynamic resistance. Output dynamic resistance. Output dynamic resistance, that is RO, output dynamic resistance, the ratio of change in potential between emitter and collector to the change in collector current IC at constant potential between at constant base current IB. The ratio of change in potential between emitter and collector to the change in collector current at constant base current IB is called as output dynamic resistance. म्हणजे आपण दोन रेजिस्टन्स पाहिले, इनपुट डायनॅमिक रेजिस्टन्स अँड आउटपुट डायनॅमिक रेजिस्टन्स. This is about transistor characteristics. Okay. Now one more point about transistor. That is transistor as an amplifier. One more point. Transistor as an amplifier. Transistor as an amplifier. See, a device which increases strength of input signal. A device which increases strength of input signal is called as amplifier. म्हणजे इनपुट सिग्नल इन्क्रीज करण्याचं जे डिव्हाइस आहे त्याला म्हणतात एम्प्लिफायर. व्हॉट इज एम्प्लिफायर? अ डिव्हाइस which increases strength of input signal is called as amplifier. त्याचे सर्किट डायग्राम. See, here also we consider common emitter configuration. Consider common emitter configuration like this. Circuit connection. Consider common emitter configuration. Base, collector, heater, emitter. Suppose this one as NPN type transistor. Heater base current. Okay. Now see. Suppose this one as input signal whose strength is to be increased is connected in series with battery positive negative forward bias potential between emitter and base current, that is base current IB, potential between emitter and base, here collector current IC. The collector current IC. Load resistance RL, negative divided bar. Output voltage is measured across load resistance. Output signal. Emitter base forward bias, forward negative positive. Base collector junction reverse म्हणजे negative negative. The potential between emitter and collector किंवा base and collector म्हटलं तरी चालेल त्या ठिकाणी. असे transistor as an amplifier. Suppose this one as input signal which is to be amplifier. Suppose this one as input signal which is to be amplifier. Suppose this one as input signal which is to be amplifier like this. Suppose this one as input AC signal, output variation with time. The current versus time. बघा circuit diagram. Amplifier, a device which increases strength of input signal is called as amplifier. Circuit connections. See, first circuit connection. Circuit consists of common emitter configuration of NPN transistor. Circuit consists of common emitter configuration of NPN type transistor. Weak signal, weak input AC signal is connected between base and emitter. Weak input AC signal which is to be amplified is connected between emitter and base in series with battery VEB. Base collector junction is reverse bias. Base collector junction is reverse bias through load resistance RL, and output voltage is measured across load resistance. Output voltage is measured across लोड रेजिस्टन्स RL. साध्या पद्धतीने सर्किट कनेक्शन आहे. काय काय केलं पाहिजे सर्किट कनेक्शन? सर्किट कनेक्शन सी सर्किट consists of common emitter configuration of NPN type transistor. Weak signal which is to be amplified is connected between emitter and base in series with battery VEB which is forward bias. Base collector junction is made reverse bias with battery VEC in series with load resistance, and output voltage is measured across load resistance. Working. Small change in base current produces large change in collector current. In case of transistor, small change in base current produces large change in collector current. First, for positive half cycle of input signal, of input signal, for positive half cycle of input signal, forward bias emitter base junction increases. During positive half cycle of input signal, forward bias emitter base junction increases, and therefore collector current increases, and hence output voltage across load resistance increases like this. For positive half cycle of input signal, forward bias emitter base junction, forward bias potential between emitter base junction increases, and hence base current increases, and automatically collector current also increases, and hence output voltage measured across load resistance increases. For negative half cycle of input signal, forward bias emitter base potential decreases, and hence base current decreases, and automatically collector current decreases, and output voltage measured across load resistance is also decreases. Means for positive half cycle, forward bias increases, collector current increases, automatically potential increases, output potential. For negative half cycle, forward bias decreases, collector current decreases, and hence output voltage also decreases. The output voltage V0 is equal to what is potential? That is current into resistance. Current कोणता? Current IC, resistance RL, current IC, resistance RL. That is output voltage is equal to change in collector current IC into load resistance RL. But you see the ratio of base current, the ratio of beta, that is the ratio of collector current to base current, and therefore change in IC, that is beta DC into change in base current into load resistance RL, where beta is current gain which is greater than 50, means output voltage increase by 50%. Thus, change in signal voltage produces corresponding change in output voltage. These changes are exactly similar. Thus, change in input voltage produces corresponding change in output voltage. These changes are exactly similar to the input signal, but get amplified across load resistance. In this way, transistor can be used as amplifier. In this way, transistor can be used as amplifier. Okay. Now, one more point, that is about logic gates. One more point, that is about logic gates. One more point about logic gates. A digital circuit which has one or more input signal but only one output signal. What is logic gate? A digital circuit which has one or more input signals but only one output signal. One or more input signals किती असतात पण आउटपुट सिग्नल मात्र एकच असतो. A digital circuit which has one or more input signals but only one output signals is called as logic gate. There are different types of logic gates that are not gate, त्यानंतर OR gate, AND gate, त्यानंतर NOR gate, NAND gate, and NOR, NAND, and one more, that is 6-1, that is exclusive OR, or XOR gate. What is logic gate? A digital circuit which has one or more inputs but only one output circuit is called as NOT gate. There are different types of gates that are NOT gate. A logic gate symbol हा झाला त्याचा सिम्बॉल. A logic gate which has only one input and only one output such that output is inverted that of input. समजा A B इनपुट 0 असेल तर आउटपुट 1, इनपुट 1 असेल तर आउटपुट 0. Means output is inverted that of input. Output is inverted that of input is called as NOT gate. What is NOT gate? A logic gate which has only one input and only one output such that output is inverted that of input. Means if input is 0, output is 1. If input is 1, then output is 0. Is called as NOT gate. Then OR gate. A logic gate which has two or more inputs. A logic gate which has two or more inputs. Suppose inputs A, B, but only one output. A logic gate which has two or more inputs but only one output, A, B, output Y, such that output is low only when all inputs are low. Such that output is low only when all inputs are low, otherwise output is high, 0, 1, 1, 0, 1, 1. A logic gate which has two or more inputs but only one output, such that output is low only when all inputs are low, otherwise output is high. AND gate. A logic gate. A logic gate which has two or more inputs, means A, B, hit the Y, symbol A, B, Y. A logic gate which has two or more inputs but only one output, such that output is high only when all inputs are high. A logic gate which has two or more inputs but only one output, such that output is high only when all inputs are high, means otherwise 0, means 0, 1, 1, 0, 0, 0 becomes 0. NOR याचं इन्व्हर्टर येतं. अ लॉजिक गेट याचं बरोबर इन्व्हर्ट करायचं. A logic gate which has two or more inputs but only one output. NOR gate is inverted that of OR gate. याचं इन्व्हर्ट हित तयार होत असतं. A, B, Y input in which output is high only when all inputs are low. ह्याच्या बरोबर हिथं अपोजिट करायचं. काय अपोजिट करतो? हिथं काय बोललो आपण? OR gate output is low only when all inputs are low. Output is low only when all inputs are low, otherwise output is high. आणि हिथं output is high only when all inputs are low. Output is high only when all inputs are low, otherwise output is low. आणि याचं इन्व्हर्टेड हित करायचं NAND गेटला. A logic gate which has two or more inputs but only one output, such that याचं इन्व्हर्ट येतं. हिथं A, हिथं B, हिथं Y. Output is low only when all inputs are high. हिथं काय म्हणतोय? Output is high only when all inputs are high. त्याच्या हिथं इन्व्हर्ट करायचं. Output is low only when all inputs are high. All inputs are high, otherwise output is high. Such a gate is called as NAND gate. आणि XOR gate, a logic gate in which output is high only when its two terminals are at different logic levels. Output is high only when its terminals are different levels. Only when its terminals are different levels with respect to each other. Output is high only when its terminals are at different levels, means output Y is equal to A complement B plus B complement A. A complement B plus B complement म्हणजेच इन्व्हर्टर. A complement B plus B complement A. XOR gate output is high. Output is high only when input terminals are different. Output only when its two terminals are different levels with respect to each other. Okay, this is called as exclusive OR gate. This gate is very useful in many different type of computational circuits. This is about logic gates. एकूण किती 6. NOT gate, OR gate, AND gate, NOR gate, NAND gate and exclusive OR gate. Exclusive OR मध्ये आउटपुट हाय येतं कधी इनपुट्स हे जर डिफरंट असतील तर, म्हणजे एक हाय आणि एक लो असेल तरच आउटपुट हाय येतं, अदरवाइज आउटपुट इज लो. इनपुट टर्मिनल्स सेम असतील तर आउटपुट लो येतं. दिस इज अबाउट लॉजिक गेट्स. ओके, रिमेनिंग पार्ट ऑन नेक्स्ट पिरियड. एक पार्ट आपला तरी बाकी आहेच अजून. ओके.